My name is Charles Henderson. I'm the Director of Application Security Services for Trustway's Spider Labs. I have with me David Byrne. David is one of my senior consultants and application pen tester and code reviewer.
So when we were submitting the paper for this talk, Charles challenged me to somehow include bright shiny objects as a phrase in the title of it. And I managed to do that, but it actually fits. GWT is a very slick technology. It has produces some of the most rich and really the best applications that I've seen using JavaScript technology. But in application penetration tests that we've done in Spider Labs, we've seen that there are a lot of developers that are using GWT that write applications that look great, but once you start looking a little deeper into them, they have some pretty significant security flaws.
And I want to be clear here. This is not a presentation bashing GWT or Google. Google is one of the sort of firms that really seems to get it in terms of security and take it seriously. And we certainly don't mean to in any way hint that they're not doing that. In fact, we respect them for doing that. But like any good technology, GWT can be misused. I like to say that in the right hands, any platform can be insecure. And that's the case here. The obfuscation aspects of GWT make it difficult to pen test in a reasonable amount of time, and the tool we're talking about towards the end of this talk should really help with that. Okay, that's finished.
Hang on.
Sorry, we're having...
I hate that rotating disc. All right. All right, when we were, no, this is, sorry, hang on a second, guys. We're having a technical problem here.
Kill the VM.
Hang on, sorry.
We're going to have to kill our background VM because...
I'll restart it in just a minute.
While we've got this up, though, before we go any further, I'd like to thank three people that really helped out with this presentation. And their names are off the screen. Matt Tesoro, Tom Levy, and Andrew Wilson helped tremendously. Matt and Andrew really helped put together these slides and get them together at the last second. I actually have another talk right after this one, so I was really sort of strapped for time. Matt also helped with the virtual machine that we're actually using the tool to test against.
It's not Matt's fault that the virtual machine is screwing up right now.
I'm guessing the virtual machine has some sort of processor or memory issue, but for whatever reason, it seems to have taken over the machine just before it's quit it.
Yeah, that's what I'm going to do. It's just bear with me just a minute. You couldn't see this, but on our side, there was incredible lag.
We weren't looking at the same slide you were. Just bring it back in the presenter tools.
I can't. We gotta wait. That has nothing to do with us.
Go live again.
There's like a ton of commands flagging behind. I think that we're okay now, though.
Investigate those. There we go. No.
No, we don't have audio plugged in for the computer. So, all right. I think we're back to normal. And we acknowledged everyone.
Okay. You want to take this?
No, God.
Okay. I don't know how many of you are already familiar with GWT, but I'm going to assume a fair amount are. We are at Blackhat. But we're just going to give a brief overview of its features. Most of GWT is dedicated to the user interface. But the security problems are actually usually found in the remote procedure call functionality. And that's a lot of what we're going to kind of focus on today, even though we're going to kind of touch on the rest. We're also going to touch on the rich internet application remoting flaws and how GWT is no different. GWT code obfuscation makes pen testing difficult, as I mentioned earlier, but it's certainly not impossible. So David actually put a tool together that makes it infinitely easier to do just that, pen test GWT applications.
I wouldn't say it's infinitely easier, but a lot easier is, I think, reasonable. Google released GWT in May of 2006. Probably best described as a rich internet application framework. Adobe Flex and Microsoft Silverlight are examples of other products in the space. Google uses the product for their Google Wave site, also for the new AdWords interface. But they also made it open source so that anyone can download it and create their own applications with it. There's a fair amount of third-party library support for it. One of the things, though, that makes GWT unique compared to most of the other players in the space is that it doesn't require a special browser plugin like Adobe or Microsoft's solution does. The client-side application is implemented entirely in traditional browser technologies like HTML and JavaScript, style sheets, and so on. What makes it even more unique, though, is that the client-side code is written entirely by the developer in Java, or at least typically written entirely in Java, which creates a pretty significant development advantage because you're basically just dealing in one language, and you don't have to find developers that are familiar with all the intricacies of client-side JavaScript when you're dealing with really complicated applications.
GWT has a number of features, and we already mentioned the JavaScript compiler. It has an extensive collection of browser UI classes from both Google and third-party libraries. A lot of other features aren't that relevant to security, but make it easy to understand why developers like and use GWT.
So I think that we actually had this slide out of order because I didn't talk about the GWT compiler yet. It's one of the more innovative and, as far as I'm aware, unique aspects of GWT in that it will compile Java code that the developer writes into client-side JavaScript that is specific to an implementation, a browser implementation, so that when the browser goes to the website, there are a number of different files that it will download depending on what type of browser it is. It's basically an auto-detect. The developer doesn't have to understand the differences in how Internet Explorer versus Chrome or Firefox renders JavaScript. It's all done automatically by the GWT libraries. There's 3 modes that the GWT compiler can run in. It can generate pretty JavaScript, which is much easier to read. It can obfuscate it, which is a big part of what the tool we're releasing today deals with. And then finally it has a detailed mode, which is mostly for debugging. And we'll get into all these in a little bit more detail later. The runtime element of the compiler, basically it will emulate the subset of Java that's being used. So that if, for example, the developer references a hash map class within their code, hash map is re-implemented within JavaScript. It doesn't implement everything within Java. It only is going to be using the classes that are defined. And it doesn't support all classes. So there are some that will throw an exception when you try to compile it with GWT just because they're not possible to run on in the browser.
Okay, this is on the screen here, and I don't know how far back you can see it, but this is an example of a simple method in Java source code for a GWT app. It's actually from the JSON sample app in the GWT SDK. The code is easy enough to read. Its intent is fairly clear, and it's just a set the text on a search button to a predefined constant, and send a JSON request. If the request throws an exception, display it to the user and then reset the search button text. So let's move forward, and this is what the code looks like after it's been compiled to JavaScript with the pretty code style. It's fairly easy to read still, but the text constant has been replaced with a static string. The function names have been changed a bit, but are still basically the same. And the exception catch is a lot longer. Part of that is because JavaScript's exception handling isn't quite as sophisticated as Java's, but there's also some replacement of once called methods that we mentioned earlier. On the whole, it's very readable code. It's not overly cryptic. And this is the same method with the detailed code style set. The main difference is that the method and class names are very long and contain references to full Java names, including the Java package. This would be great information for a pen tester, but I wouldn't count on seeing it because it's generally going to be used by developers for debug mode, and it's going to increase traffic a great deal. So they're probably not going to leave it on for you. Recognize this. It's the same thing. The JavaScript keywords don't change, but the rest of it makes no sense at all. You'd have to track down 4 global functions, 5 classes, at least 6 fields of those classes to understand this. Most of that information is going to be just as readable as this. It's not impossible. In fact, David did it recently on a test, but it took so long that he actually wrote the application that we're releasing today. So I guess the end result is, how do you come up with this? How does obfuscation work? Well, it's a miracle like magnets and rainbows.
And blankets, too. How do they work?
Actually, it's fairly easy to understand. Well, not really. It's fairly straightforward, at least. There are 4 main things that Google does to obfuscate the code. All of the method names, variable names, and class names are replaced with short, sequentially generated names. AA, AB, AC, etc. Larger apps can have 3-character global names, while local variables just have 1 character.
Most of the static strings are also moved into globally defined variables, just in 1 block, so that if they're reused, they only have to be defined once. All the extra white space is removed. The only exception to the white space rule is that each function appears on its own line, which isn't a requirement of JavaScript. And then the final step, which when I first started looking at this, I thought it was just sort of a final screw you at anyone trying to decipher it, is that the functions are all sorted within the page by size.
You know, if you're paying close attention, you may have noticed that the last step is solely used for obfuscation. The first 3 are also used for code compression. Since GWT can generate massive files, it's important to reduce transfer times as much as possible. And of course, if anyone's going to understand how to do that, it's going to be Google. If you're really smart, or if you've read the comments in the GWT source code, though,